Opening sequence, ambient, haunting music. Slow zoom from a person sitting in a quiet room out through the window, into the night sky, past the moon, past Mars, leaving the inner solar system behind. Narrator. As you listen to this, Saturn floats 800 million miles from where you are sitting. If you left Earth today traveling at the speed of a bullet, you would not arrive for over 50 years. Every spacecraft humanity has ever sent to the ring giant required between 3 and 7 years, just to get there. And Saturn is not even far by cosmic standards. It sits in our own solar system, orbiting the same star that warms your face on a summer afternoon. This is our neighborhood. This is close. The distances separating us from this neighboring world are so vast that they break every intuition your brain evolved to process. The true journey time depends entirely on how fast you are willing to go. And at most speeds we consider fast, your bones would turn to dust long before arrival. If you want to understand just how isolated we are within our own cosmic backyard, this journey through the void will reveal truths about existence that may change how you see everything. Are you ready? Let's begin. Visual, animated solar system. Orbits of Earth and Saturn highlighted. The distance between them pulses, growing and shrinking. Narrator. First, a fundamental obstacle, Saturn does not sit at a fixed distance from Earth. Both worlds orbit the Sun at different speeds, on different paths. The gap between them is a constantly shifting chasm, spanning hundreds of millions of miles. When Earth and Saturn align on the same side of the Sun, an event astronomers call opposition, the distance shrinks to about 746 million miles. This is our closest approach. The optimal launch window. But when they occupy opposite sides of their orbits, with the Sun blazing between them, that distance stretches to nearly 1 billion miles. The difference between close and far is over 250 million miles, a gap wider than the entire inner solar system. On average, Saturn is 886 million miles away. Scientists call this 9.5 astronomical units. 1 AU is the distance from Earth to the Sun. We use this unit because our brains cannot truly comprehend numbers with 9 digits. We lack the framework for distances that require hours for light to cross. Visual, a person on a dark hill, looking at stars. The camera pulls back at the speed of light. Planets whiz by as time stamps appear, light from Moon, 1.3 seconds ago. Light from Sun, 8 minutes ago. Light from Saturn, 80 minutes ago. Narrator. Consider what 886 million miles means. Light itself, the fastest thing in our universe, traveling at 186,000 miles per second, takes over an hour to cross this gulf. When engineers at the Jet Propulsion Laboratory send a command to the Cassini spacecraft at Saturn, they transmit, and then they wait. 80 minutes. Just to hear if it was received. Another 80 minutes before they know if it worked. To put this in more tangible terms, imagine driving around Earth's equator. That's about 25,000 miles, a 17-day continuous drive. Now, imagine making that trip 35,000 times in a row. That is the distance to Saturn. If reaching the moon is like walking to your mailbox, reaching Saturn is like walking from New York to Los Angeles and back. 17 times over. Visual, scale model. A basketball sits alone. A peppercorn, Earth, is placed 26 yards away. The camera tracks back, and back, and back. 240 yards total, to a marble, Saturn, sitting in lonely darkness. Narrator. Let's shrink the solar system to a comprehensible scale. If the Sun is a basketball here, Earth is a peppercorn, 26 yards away. You could see it, just barely, at the length of a tennis court. Saturn. A marble. It orbits 240 yards from the basketball Sun. That's 2.5 football fields of pure emptiness. At this scale, the entire inner solar system, Mercury, Venus, Earth, Mars, fits within about 50 yards of the Sun. Saturn floats alone in the cosmic suburbs, The void between our worlds is not an emptiness of possibility, it is an emptiness of everything. Visual, a spacecraft interior. The sound of breath in a suit. Then, sudden absolute silence. The view out the window is pure black, punctuated by unwavering stars. Text appears, temperature, 250 degrees Fahrenheit in sunlight / minus 455 degrees Fahrenheit in shadow. Narrator. If you could stand in that void, the experience would be unlike anything on Earth. No sound. Sound needs air. No wind. No weather. Just radiation. The side of you facing the sun would blister, the side in shadow would freeze near absolute zero. You would float in perfect silence, surrounded by stars that don't twinkle, because twinkling requires an atmosphere. The nearest solid object might be millions of miles away. The loneliness would be absolute. Not the loneliness of an empty room, but the loneliness of being the only organized matter for distances that dwarf all of human history. This is the void a spacecraft must cross. Visual, animation of the rocket equation. A simple graph curves upward exponentially. Stack of fuel tanks grows impossibly high compared to a tiny payload. Narrator. And crossing it requires confronting a cruel law of physics, the tyranny of the rocket equation. Chemical rockets, our only proven method, face a fundamental limit. Their exhaust speed can only be so fast. To go faster, you need more fuel. But that fuel has mass, which requires more fuel to push it. The relationship isn't linear, it's exponential. Doubling your speed doesn't double your fuel need, it may quadruple it, or more. For a direct shot to Saturn, the fuel required would be so immense, so preposterously heavy, that no rocket could ever lift it off the Earth. So, how do we get there? We become cosmic pickpockets. Visual, complex, looping flight path animation, Cassini's trajectory. It swings past Venus, twice, Earth, then Jupiter, each encounter providing a speed boost. Narrator. We use gravity assists. By flying a spacecraft close to a planet on a carefully calculated path, we can steal a tiny fraction of that planet's orbital momentum. The spacecraft gets a huge boost in speed, for free. The Cassini mission to Saturn is the masterpiece of this technique. Launched in 1997, it did not go straight to Saturn. Instead, it took a grand tour. It flew past Venus, twice. It slingshot past Earth. It used the mighty gravity of Jupiter for one final push. This cosmic detour added years to the journey, but it made the mission possible. Cassini arrived at Saturn in 2004. Total travel time, 6 years, 9 months. 7 years of patient, silent crawling across an ocean of nothing. Visual, montage of iconic Cassini images, Saturn's rings backlit by the sun, the haze of Titan, the geysers of Enceladus. Then, a slow pullback from Saturn, showing the dot of Earth in the distance. Narrator. And what did we find? A world of breathtaking beauty and profound mystery. Rings of ice and dust, thinner than a sheet of paper scaled to their size. Moons with methane lakes, and subsurface oceans that could harbor life. A system that became, for a time, our distant outpost in the dark. But that outpost operates in a permanent state of delay. A perpetual past tense. The spacecraft you are controlling right now is responding to commands you sent before lunch. The data you are receiving describes a situation that existed before your afternoon coffee. In the emptiness between worlds, you are always alone. There are no rescue missions. Every decision must be pre-programmed, every contingency planned for years in advance. Final sequence, the camera continues pulling back from Saturn, now a dot. The solar system shrinks to a point of light. The Milky Way appears. Narrator. So, how long does it take to get to Saturn? At the speed of a bullet? 50 years. With our best rockets on a direct path? Still years, and an impossible fuel bill. With gravity assists and brilliant planning? almost 7 years. But the true answer is deeper. It takes the patience to wait for planets to align. It takes the humility to follow looping, indirect paths because the universe does not grant straight lines. It takes the acceptance that you will launch a piece of human genius into the dark, and for nearly a decade, you will simply wait. Saturn is in our neighborhood. It is one of our closest cosmic neighbors. And yet, the gulf that separates us is so vast, so empty, and so silent, it reminds us of a fundamental truth. We live on an island. A beautiful, warm, vibrant island in a shoreless sea. And the nearest other island is 1 billion miles away. Music swells gently, then fades to silence. Final shot, the pale blue dot of Earth, suspended in a sunbeam.